Hello guys, welcome back to this channel. I'm really grateful for all of you being here watching this video, trying to learn a little more about math. Like I said, this channel is all about being simple, explaining harder concepts, even though the one we're doing today is aimed at lower grades. But I just want to emphasize that this channel is here for every grade, it's for anyone, and whatever your recommendations you have or questions you have, I will be making videos on those. So yeah, again, I'm here for everyone. So yeah, let's dive into it. Today's topic is going to be about fractions, their equivalents, and comparing them. Now, the first matter at hand before we really get into anything is just explaining what a fraction is. So, the best way I can explain it as of now is a fraction is just a portion or piece of something whole. I'm going to represent this through two drawings, okay? So the first drawing I have here is a box. As you can see, this box is whole. It's full. The whole thing is full, right? Now, to make it a fraction, what I'm going to do is split it up into just small pieces. We're going to do 4 pieces. 3, 4. Okay, now we have 4 pieces. So we had our whole box, this whole thing. And we've just split it up into pieces. Now, if I shade just one piece of it, all I'm technically saying is that I'm taking one piece of the whole box. Now, how many pieces are in the whole box? 1, 2, 3, and 4. So I've taken one piece out of 4 pieces. There were 4 pieces in the beginning, or one whole box that was split up into 4 whole pieces, and I've taken one of them. Now, if I take 2, I've taken 2 pieces out of 4. The denominator doesn't change, just the numerator as I keep taking pieces. Now 3 goes to 3/4 and 4, making it 4/4. Now 4/4, as you see, is basically the whole box shaded. That simplifies to 4 over 4 equals 1. The reason mine simplifies to 1 is because it's one whole box. We've shaded one whole box, and that's why it goes back to that one original whole box that I've been talking about. Now I'm going to represent it through a pie or pizza, which is like usually how teachers explain it worldwide. I feel like everyone uses a pie, and it's a really good way to explain it. Now, if we have this one whole pie right here, one whole pie or pizza, and I'm going to split it up into pieces. So I'm going to do 1. These aren't perfectly equal pieces. Don't worry about it. I have 2, 3. Okay. So now I've split it up into 8 pieces. This one whole pizza has now gone to 8 pieces. If I take one piece of that pizza, if I eat one piece, I've eaten 1 out of 8 pieces of a whole pizza. If I take 2, that's 2/8. If I take 3, that's 3/8, and so on and so forth. That's how a fraction works. So again, a fraction is just a simple portion of something whole, like this pie or this box. It's been split up into different pieces, and I've taken some of those pieces away. Therefore, I'm taking away from what is whole. It's just a portion. A fraction is a portion of something. That's all I want you to understand. Hopefully that makes sense now. So now that you've got like a general concept of what a fraction even is, this is a whole nother topic. It's kind of a harder level. It dives more into like specific fractions and specific situations. So I feel like you would first need to grasp like what an actual fraction is before you go into this. So make sure you've got a really good understanding before you go into fraction equivalence. Now, the best way I can really like depict this really is through a visual model. That's kind of how I explain fractions in the best way possible, because if you just start writing numerical values of fractions, it will get like kind of tricky for those who don't know what's going on yet. And that's why I always use these models, which boxes or pies or pizzas, that's the best way to work with it. So to start off, I'm going to cut my boxes into pieces again. This one's going to be split into 2 pieces. This one. And the other one is going to be split into 4 pieces. So 1, 2, 3, All right, 4. There we go. So how can I show fraction equivalence? Well, the way I can show it is that if you shade in 1/2 of this first box here, and you shade in 2 pieces of this box here, do I have the same value? Technically, yes. Yes, I do. Because both of the shaded parts end at the half of the box. Even though I shaded 2 pieces here, it still equals the same amount as the first piece here. Why? Because the pieces of this one are larger. Although there's only 2, they are larger in size. And, let's go up. They are larger in size, and these are smaller in size, so therefore you need to use more pieces or shade in more pieces in order to match this amount. And that's what equivalence is. It's basically telling you that difference in numerical fractions, they can still have the same value. That's what it's telling you. So here we have 2 pieces of 4 whole pieces, this bottom one right here. But at the top, we have 1 piece of 2 whole pieces of the box. So you're telling me that 1/2 is equal to 2/4. Why? Because they have the same value. I just showed you that they still represent the same amount of shaded volume right here. And that's what it is. That's all equivalence is. So you can solve fraction equivalence by either A, drawing these box models, or pies, pizzas, anything you want, and just kind of eyeballing it. Like, are they the same? Do I still have the same shaded amount of area? And yeah, you could do that, but I feel there's a better way, especially with tests, homework, where you don't have to spend minutes drawing this stuff and shading it in and then eyeballing it, which can not always be accurate. And that's why the best way to do it is through something called simplifying. So if I were to take these 2 examples, again, I had my 1/2 of a box and I had 2/4 of a box. What simplifying basically is you're taking a numerical fraction and breaking it down into something smaller in a numerical way, but the same value. That's kind of hard to explain, but the best way I can explain it is that same thing, just smaller numbers. So 1/2, so smaller numbers 1 and 2 is the same as 2/4, bigger numbers 2 and 4. Now, how can I simplify 2/4 to show that it's equivalent to 1/2? The way you could do it is by finding the greatest common factor between your numerator and denominator. Your numerator is always the top number of a fraction. So in this case, 2. So I'll label that n. And your denominator is the lower part of the fraction. Actually, I'll circle it, and I'll name that d. So lower number of a fraction is denominator, and upper number is a numerator. Now, the best way to simplify is, I'm pretty sure I said it already, so you want to find the greatest common factor between 2 and 4. The greatest common factor is basically a number that multiplies to both numbers, but it's also the greatest number that can be multiplied to those numbers, which in this case would be 2. Why? Because 2 times 1 equals 2, right? So we get our numerator right there. But also, 2 times 2 equals 4. So we get both our numerator, and now we've got our denominator. So it has to be 2, because it can be multiplied to both of those numbers. Now, what do? Now, once that we figured out that our greatest common factor, or GCF, I'll just put a shortcut, greatest common factor is 2, we divide both the numerator and denominator, emphasis on both. You have to do both. If you only divide one value, you will get you'll get, how could I say this? You'll get something way different. Way different. Because you're changing the whole value of the fraction just by changing one number. You want to change them both similarly so that it still ends up being an equal amount in ratio. So 2 to 4 or 1 to 2. So it's still half value. That's what I'm kind of saying here. That's kind of complicated, but hopefully you understand what I'm saying here. So now that what I want to do is just divide your numerator, so 2, and your denominator by the greatest common factor. So 2 divided by 2 equals 1, and 4 divided by 2 equals 2. And there we have it. Our answer is 1/2. So basically 2/4 simplified is 1/2. It same goes for 3/6. I'll just stay red now. So the greatest common factor between 3 and 6 would be 3 itself, because 3 times 1 equals 3, and 3 times 2 equals 6. So if our greatest common factor is 3, then we divide. 3 divided by 3 equals 1, and 6 divided by 3 equals 2. And we still end up getting 1/2. That's just saying that the value of those differently numerical fractions still ends up being 1/2. You still have 1/2 of that whole box plot. And that's what I'm getting at here. That different numerical fractions can still be the same in value. That's what's most important when you're looking at fractions, the value. And these are the two ways to solve it. You can either draw box plots or pies, or you can go into simplifying and just making sure that you have your two numbers where you have 1/2 and then your other number can simplify to 1/2. All right. And the last topic of the day is going to involve comparing fractions, which is basically just like the finale, the main build-up of what we've been getting at here for this whole video. If you understand the previous two topics, this should be pretty simple for you. Yeah, let's get into these visual models again, just to start off the situation and what comparing fractions is, how to do it, and just some tougher problems with it. So if I were to break up this pie or pizza model into, let's do, how many pieces should we do? I'm going to do 8 pieces, so that, they're not perfect pieces, again. I'm not a perfect drawer. And then I split up the second one into 4 pieces. And I shade in 3 pieces of the first model, which the fraction would be, hopefully you know this by now, 3 over 8 whole pieces. And I shade in 3 of the 4 pieces of the second model, making it 3 over 4 pieces. So we have these two fractions now. And if someone, let me fix that. And if someone were to ask me, well, how would I compare these fractions? Which one's greater? Which one's smaller? Visually, yes, you can probably see that 3/4 is way larger and covers way more surface area than 3/8, therefore making it the larger fraction with more value. However, if you can't really eyeball it through a visual depiction like this, then you've got to turn to something called finding the common denominator between fractions. Now, how do I do this? First, let's list our fractions. So we have 3/8, 3/4. Now, I can't really just immediately compare these fractions due to the fact that they have different denominators, placing them at kind of different values and a different way to be seen. What I want to do is kind of level them together, make them easy to compare. Right in front of my eyes, I can see which one's immediately greater. Because it's kind of harder to compare the 3/4 because you have only 4 pieces rather than 8. So that makes it way harder to compare. So how do I make them kind of level to each other, easy to see which one's greater and which one's smaller? Well, what I want to find is the common denominator. So we've learned that the denominator is the lower number of the fractions. So in this case, it would be 8 and 4. Now what a common denominator is, it's just a denominator or a number that both of these denominators can get to. So 8 and 4. Now in this case, you want to usually look for the smallest common denominator. In this case, it would be 8. Now why is it 8? The reason why is because 4 can get to 8, but 8 can also get to 8. How can 8 get to 8? 8 times 1. 8 times 1 equals 8. How can 4 get to 8? 4 times 2 can get to 8. So our common denominator sits at 8. Therefore, we don't have to touch this fraction at all. In some cases, you do. In some cases, you do have to multiply both fractions, which is what we're going to do here for only one of these fractions. We want to get this 3/4 into a denominator with 8, and then we can just compare numerators. That's what you want to get at when you're comparing. You want to compare numerators only without having to worry about denominators. So how do you do that? You make your denominators the same. So if I want to get 3/4 to a fraction with a denominator of 8, all I have to do is multiply both, again, emphasis on both, so you don't change the value of the fraction, both the numerator and the denominator by a number that gets the 4 to 8. That number is 2, as I've stated previously, right? 4 times 2 equals 8. That means I have to multiply this whole fraction, so 3 over 4, by 2. How do I do that? I first focus on my numerator, I multiply it by 2, and then I focus on my denominator. I multiply that by 2, making it equal 6, because 3 times 2 equals 6, over 8, because 4 times 2 equals 8. Now, we're sitting pretty. This is an easy situation now. This makes it way easier to compare. We had 3/8 first, and we had 3/4. We didn't know what to do with it unless we drew it out visually. But if you don't want to do it, you want to take less time, and you want to solve this problem more efficiently, this is what you do. You just find the common denominator, and now we're sitting at 3/8 and 6/8, which was originally our 3/4. Immediately, we can tell that 6 is greater than 3. That's all we have to do. Compare the numerators, and boom, we've got our comparing. 3 over 8 is less than 6 over 8, or 6 over 8 is greater than 3 over 8. That's it. That's how you compare fractions, either visually or through finding the common denominator. Thank you guys so much for watching. I really encourage you to keep being motivated about learning math. I'm really appreciative of your support. This is a new channel, and we're really getting it up and running because of you. I hope that you can like and subscribe so we can make this channel more accessible for others in need of help, and for you so you can continue to improve on your math skills. Thank you guys so much. Have a good one.